form to another. It also includes entropy, which is a measure of order and disorder and basically tells you how useful different kinds of energy are. Energy is a fundamental property to physics, and although I've written energy here, I should have written it everywhere on this map, because everything has energy. So that's all of classical physics, the picture of the universe we had around the year 1900. It told us we lived in a universe where everything ran sort of like clockwork. If you could measure everything accurately enough, the future was kind of predetermined. However, not everything was solved. There were just a few holes in experiments that hinted at something more. The orbit of Mercury was slightly too fast, and some strange things happened on the smallest scales with electrons and light, which were all unexplained. Physicists at the time thought that they'd solve and explain these problems soon enough, but poking at them, they unravelled the new domains of relativity and quantum physics and turned our understanding of the universe completely on its head. Albert Einstein was the genius who developed the theories of special and general relativity. Special relativity predicts that the speed of light is constant for all observers, which means that when you travel really fast, weird stuff starts happening, like time slowing down. It also states that energy and matter are different aspects of the same thing, through the famous formula E equals mc squared. General relativity says that space and time are part of the same fabric, called space-time, and that the force of gravity comes from objects bending space-time, making other objects fall in towards them. While relativity describes the very big, other physicists were busy at work on the very small in the world of quantum physics. Atomic theory probed the nature of the atom, and more detailed descriptions of the atom were developed, from a tiny sphere to electron orbits, to energy levels, and then to the electrons being wave-like charge distributions. Condensed matter physics describes the quantum physics of many atoms together in solids and liquids, and is where many great technologies have come from, like computers, lasers, and quantum information science. Nuclear physics describes how the nucleus of atoms behave and explains radiation, nuclear fission, the splitting of an atom used in our nuclear power plants, and nuclear fusion, which takes place in the Sun and will hopefully soon be harnessed here on Earth. Particle physics probes even deeper to find the fundamental subatomic particles that everything is made of, and are described in the standard model of particle physics. And quantum field theory captures